Finally, for this lesson, let's talk about how the graphs of logs compare to the graphs of exponential functions. Exponential functions rise slowly, and then all of a sudden they get real sharp, whereas logs start the other way. They rise sharply, and then they kind of keep rising, but at a slower level as x gets further. So a couple takeaways here: 2 to the x power. Since the base of that is 2, the inverse of that is log base 2 of x. And just a couple of points worth mentioning. Think of the point 0, 1. If you switch the x and y values, that's the inverse. 1, 0 is on the other function. Here's another point, 1, 2, and 2, 1. And we can come up with maybe one more point, 3, 8. Basically 2 to the third power, 2 times 2 times 2, and 8, 3. So hopefully you see that relationship where the x and the y values switch. And because they're inverses, they're going to be reflected over this line, this diagonal line, y equals x. You might remember that from our first unit. But inverses always reflect over the line y equals x. It's a diagonal line. So compare that on the graph here. It's the same graph. If I were to throw the line y equals x, you'll see a diagonal line splitting the difference. You could even check a couple points if you drag over it, 0, 1, 1, 0, 1, 2, 2, 1. So they are going to be inverses of each other. And it doesn't matter what the base is. If the bases are the same, 2 to the x, or 3 to the x, and then log base 3 of x, those two are going to be inverses of each other. Got to keep the same base. So, if that's a 6, then that should be a 6. So they'll always be reflected over the line y equals x. You can also have inverses of the transformed graph. So let's say I moved the graph down 3. So let me do 2 to the x minus 3. So if I shifted that down 3, then in order for the inverse graph to be in the log, I would have to have plus 3 in the parentheses. You can see that these are mirror images over each other when I do the plus 3 in parentheses. So think about what's going on here. Minus 3 for the exponential, let me hide these. It shifts down 3. So for the log, because they're reflected over the line y equals x, shifted left 3 is the same, is providing that reflection. So down 3 on the y-axis is reflected to left 3 on the x-axis. So that's why those are inverses of each other. And again, you can just kind of pick a couple points, 0, negative 2, negative 2, 0, 0, 1.585, 1.5850. So you can see those are just the reversed numbers of each other. So look at the opposite signs in there to kind of help you out with that. If it's minus 3 on the outside, it's going to be plus 3 on the inside of the parentheses in the log, and vice versa. So that applies to any movement, right? In this case here, if I go right 3, so if I put x, if I raise it 2 and I put in parentheses x minus 3, that's shifting the exponential function right 3. That means I want to shift my log function up 3. So right on the x-axis, inverses up on the y-axis. Again, those are inverses of each other. You can see that there. And you can combine operations. So look at these two functions, 3 to the x plus 2 minus 1, and then log base 3 x plus 1 minus 2. So if you look really closely at these numbers, what was outside goes in, what was inside goes out, and the signs are both going to switch on those. So what we're looking for is that nice reflection mirror image over the diagonal line to show that those are inverse of each other. Again, another one here just to kind of see 10 to the x minus 4 plus 2. That minus 4 becomes plus 4 out here, and the plus 2 becomes minus 2 in there, same base. And those are mirror images of each other over the line y equals x. So let's do an example. Let's write the inverse functions. So if we want to do the inverse function, notated f negative 1x, if you don't have any movement, so if you have 3 to the x power, its inverse is going to be log base 3 of x. We don't have to do anything with adding, subtracting, or any numbers inside or outside because there is none being done there. Let's check that on the graph. So if I did 3 to the x power and log base 3 of x, and put y equals x for good measure so you can see that relationship, and those are reflected over that line. So we're good on that one. Try this one. It's still going to be log base 3. What will go in the parentheses? Plus 4, and then on the outside will be minus 1. So 3 to the x plus 1 minus 4. That inverse is log base 3 of x plus 4 minus 1. Let's type those out. I'm going to put the x plus 1 in parentheses so you can see that right shift. And then it's going to be minus 4 on the outside. And we want to match that in here in the log. So we'll do x plus 4. And then we want to do minus 1 on the outside. So you can see that nice mirror image over the line y equals x. And a couple points here just to kind of show that they are switched from each other. Excellent, excellent. Try this one on your own. This will be our last one. Okay, hopefully you've got a chance to pause the video and try it on your own. Let's check it. So we'd say log. What's your base? Still going to be 2. So we have an x in there. Now what do we do with that x? Well, this plus 4 is on the outside in the exponential. So we actually got to take it inside and do minus 4. Now, because I don't have anything up here, I don't have anything to add or subtract at the end. There is no right or left movement, so there's not going to be any up or down movement. So your inverse is simply going to be log base 2 of x minus 4. Let's check that. I like to check those on a graph and look for that mirror image. So we're going to write, 2 to the x power plus 4. And let's pull that down. And then we're going to do log base 2 of x minus 4. And if you're not sure if they're mirror images of each other, throw the line y equals x in. Usually you can tell by that line if there's anything that's a little bit off. For instance, if you had said plus 4 in here, that's not reflected over the line. So minus 4 is good on that. If you said, maybe you made a mistake and you said minus 4 out here, not quite, right? They're a little bit off, right? Or if you said plus 4. So you can tell by having this line, this diagonal line in there, if they're inverses of each other. Well, very good. Go ahead and complete the 5.5 practice on Canvas.